All right, welcome back. We're going to do a little polynomial arithmetic where we divide one polynomial by another. That can be expressed as a fraction. Fraction bar is division. So we're dividing 10x squared plus 11x minus 6, all divided by 2x plus 3. We can set that up with long division just like we would with a base 10 number situation. So we're going to put our numerator 10x squared plus 11x minus 6 underneath this division symbol so that we can do some long division, and then we're going to divide by that. What you divide by comes here, so we'll put 2x plus 3 right there, and then we're going to think through each of these are essentially place values. We've got an x to the 0 column, x to the first, x squared. So we have to multiply 2x by something to give us 10x squared so that when we subtract, it will cancel the 10x squared. So 2x times something gives us 10x squared. 2 times 5 is 10. X times x is 2. So I'm going to have an x to the first, so I'm going to put that right here. And I'm going to put my coefficient 5 on it. So 5x times 2x plus 3 is going to go here. This is 5x times 2x plus 3 is what we put on this line. 5x times 3 is 15x. 5x times 2x is 10x squared, which was the whole point of picking 5x, so that when we subtract what we've accounted for, the x squared column is totally satisfied. It's done away with, and we get 11x minus 15x is negative 4x. 10x squared minus 10x squared is 0. And then we have negative 6 minus nothing. We don't have any holes here, so the negative 6 carries down just like it would if this was a regular base 10 long division problem. Okay, now we've got this expression, and we're trying to divide it by 2x plus 3. So something times 2x has to equal negative 4x. Well, I've got the x, so I'm going to multiply this by a whole number to get that. So my whole number goes here. 2x times something gives me negative 4x. That must be negative 2. So we're going to put on this line negative 2 times 2x plus 3. Negative 2 times 3 is negative 6. Negative 2 times 2x is negative 4x. That was the whole purpose, because we want it to cancel. So when we subtract that product, we get negative 6 minus negative 6. Minus a negative is addition, so negative 6 plus 6 is 0. Negative 4x minus negative 4x is also 0. So we have nothing left over, right? We took negative 4x minus 6 and subtracted itself. If you subtract something from itself, you get to 0. All right? That means that this fraction simplifies to 5x minus 2 with no remainder, right? The remainder was 0. Okay, so that's the solution to this. They don't always have a remainder of 0. We'll talk about that in a future video. But I want to point one other thing out while we're on this one, and that is that these expressions are equivalent. They're going to give you the same number as long as you put the same number in for x in all of these spots. If you evaluate that fraction, it will equal this one. But you can't have a denominator that's equal to 0, so we have to add a little stipulation here, a little condition on it. 2x plus 3 can't be 0, otherwise this fraction would be undefined. It wouldn't be a number at all, because we don't know what dividing by 0 means. So we'll do a little side work here. 2x plus 3 equals 0. That's not okay. So we're going to figure out this, we'll say that's not equal to 0. So 2x is not equal to negative 3. Subtracted 3 from both sides. So x cannot be negative 3 halves. All right? So we'll add that condition. So we'll say this fraction equals 5x minus 2, where x is not equal to negative 3. And we're done.